All right, we're going to start with the second problem. So it's a clipper problem. We have AC signal source, which is Vm is equal to 10 volt. So it's a 10 volt to minus 10 volt and sine wave. And we have one diode. So diode is oriented in this in anti-clockwise directions, one DC voltage source and resistors. And output voltage is taken across the DC voltage source plus the resistors. And that means V0 means this terminal voltage with respect to ground. And we said that we're going to solve it.
Sir.
Yeah, Balan.
Sir, V0 5 volt आगे क्या? Sir,
no, when I say V0, it usually means this terminal voltage.
So shop ক্ষেত্রে এরকম বলবো?
Yeah. Generally, V0 means any terminal voltage.
Okay, sir.
From here to here. It looks. I know it looks confusing.
What about the element between the terminal?
If there is mention, say for example, if I wanted to measure the terminal voltage, let's say I would stick out one terminal like that. Okay? I would stick out one terminal like that. In that case, it would mean that this is the terminal we want to measure the output voltage of. Yeah, then in that case, it will be only across the resistor. So now it is across the resistor plus the.
স্যার তাহলে তো মানে কোন জায়গার ভিতরে জিনিসটা মেজার করতে হবে তো ক্লিয়ারলি বলা থাকবে।
হ্যাঁ, বলা থাকবে। Yeah. So let's say isn't that easy? Wouldn't that be obvious if I let's say instead of writing it here, if I put it there? So it means the whole, starting from the ground till this terminal. Then it would be much more easier instead of writing it here. Okay, so if I go about trying to solve the problem, the first thing that we said that we have to do, what are the steps? Just try to follow the steps. So determine T as V. So at T as V, Vd is equal to 0.7 volt and Id equals to 0 milliampere. That means first thing that we're going to determine is the transition state voltage. And we know at transition, the current through the diode is 0, but the voltage across the diode is 0.7. So what we are trying to do here? So we see the voltage is fluctuating between 10 volt to minus 10 volt in that signal. So when it is fluctuating between 10 volt to minus 10 volts, we want to find out at what value of Vi we have our transition of the diode occurring. So I want to find out the Vi. So Vi is pretty much unknown. I want to find out when the signal is fluctuating between 10 volt to minus 10 volt, at what value of Vi we have our transition. So let's assume that our diode is going through transition. So for that, I'm going to redraw the circuit. So if I redraw the circuit, replace the diode with 0.7. Okay. 0.7 volt Vi, and let's say this is I, which is 0.5 volt R. So let's assume the Vi is positive. That's the thing that we should always be doing. Although we know the Vi has positive value as well as negative value, and I don't know what value of Vi we are going to have transition. So for that, I just assume that our Vi is positive. Just assume that. And accordingly, we're going to apply KVL. If I apply KVL, so plus Vi, because we are going from negative to positive, plus 0.7, again negative to positive, plus minus, so minus 5 minus IR, and plus minus equals to 0. However, we know that IR is equal to 0 because the current to the diode is 0. So we have Vi is equal to 4.3 volt. So now I know when the signal is fluctuating or changing between 10 volt to minus 10 volt, when the input signal reaches at 4.3, in that case we have our transition. So next step would be to draw our transition state line. So 4.3 is above or below? Above. Above. So this, since it has come positive, it should be above. If it had come negative, then it should become below. So now we are going to just qualitatively, without any scale, just roughly we put it somewhere here. This is our next step. Transition state line. So that means this is our Vi is equal to 4.3 volt line. Next, I need to find out. So we already learned that transition state line tells us what? It gives us the boundary between the on state of the diode and off state of the diode. So this is the boundary between the on state of the diode and the off state of the diode. So how can we determine the boundary? By looking at into the orientation of the diode. We already learned that if we keep our AC signal source to our left, and if we find the diode is oriented in anti-clockwise direction, like this one, the diode is oriented in anti-clockwise direction. In that case, all the value of signal below the dotted line or below the transition state voltage line, the diode will be on or off. On or off? I'm asking you.
Off.
Off.
On.
On. So if it is anti-clockwise, in that case, dotted line er niche or all the voltage diode will be on, and if it is anti-clockwise, all the value of the signal above the transition state line, diode will be off. So now I know the range of input voltage when the diode is off and the range of input voltage when the diode is on. তার মানে এই লাইনের নিচে, this line, below this line, whatever the voltage you have, this point, any point you pick on the signal, for this particular value, you will find the diode is on. So now I know the boundary. So mathematical, I can write Vi less than 4.3, diode is on, and Vi greater than equal to 4.3, diode is off. You see, this is how I can mathematically relate. Say any of value of Vi which varies between Vm to minus Vm and which is valid during this interval. So if you find any value of Vi less than 4.3, you can say for that value of Vi, this diode will be always off. And any value of Vi greater than equal to 4.3, which which is valid T1 to T2, in this range, T1 to T2, you see all the value of Vi, where do they lie? Above or below the dotted line?
So below the dotted line.
No, above. So isn't that above? Dotted line এর উপরে এই পয়েন্টগুলো আমি দেখেন, আমি তো জাস্ট পয়েন্ট, আমি পয়েন্টিং দ্য পয়েন্টস, পয়েন্টিং দ্য লাইন। সো আমার পয়েন্টটা কোথায়? এই ডটেড লাইনের উপরে না?
T1 and T2.
Yeah, T1 and
Yes, sir.
T1 and T2
Yeah.
interval, all the value of the signal is above the dotted line.
Above the dotted line.
So that means for that value, diode will be off. I can write it in terms of time, 0 to T1. So during this interval, and also during this interval, এই যে আমি ইন্টারভেল ডট এই ইন্টারভেলের মধ্যে দেখেন all the value of vi is dotted line এর নিচে, তাই না? all the value of vi এই dotted line এর নিচে, এই dotted line এর নিচে vi is equal to 4.3 voltage line এর নিচে. So in that case the diode will be off. So I can write T1 to capital T. T is greater than T2. This is our T2 less than the capital T. However, for T1 and T2, all the value of signal is above this transition state voltage line. So the T1 is greater than T1 and less than T2. So I have figured out the range of input signal for which the diode is on and the range of time for which the diode is on. I have figured out range of input signal for which the diode is off and the range of input signal for which the range of time, the duration of the time for which the diode is off. Okay. So the next thing would be to draw the input-output relationship. So input-output relationship.
একটা কোশ্চেন
Yes.
স্যার সাপোজ আমার যদি ভোল্টেজ মানে ভিআই যদি নেগেটিভ আসতো তখন কি মানে ডটেড লাইনটার সিচুয়েশনটা কিভাবে হতো? ওরিয়েন্টেশন ডায়োডটা সেমই যদি থাকতো।
Same, it doesn't, you know, vi, whether vi is positive or negative doesn't matter. All it matters if the orientation of the diode. If the orientation of the diode, you know, if the orientation
সবসময় মানে
yeah, anti-clockwise direction এটা যদি নেগেটিভও থাকতো, for example I just draw it here. So let's say it is vi is equal to minus 5.3 for example. We've obtained a transition state voltage which occurred at minus 5.3. It would be the same, you know, since why? Because the orientation of the diode is still anti-clockwise direction. In that case, upper, above it will be off, below it will be on. So it's nothing to do with
জাস্ট ফ্লিপড হয়ে যাচ্ছে,
হ্যাঁ,
জাস্ট ফ্লিপড হয়ে যাচ্ছে আর কি যখন
not necessarily flip. No, it doesn't flip, you know, still it is off here, it is off here, it is on here, niche on, upore off. Then both cases it's on for the voltage below the transition state voltage line. Here as well it is on for the voltage below the transition state voltage line. It is off for the voltage above the transition state line. It is also off, but in that case only thing is that range is different. So for example, the range হচ্ছে in terms of time wise, range হচ্ছে from here to here for all the voltage diode is off. Again from here to here for all the voltage diode is off, and the diode on only for this range. Okay.
ওকে স্যার।
So it is nothing to do whether the vi is equal to 4.3 or vi is equal to minus 5.3 line is above or below, you know, the positive axis or negative axis. All you have to check in terms of the orientation of the diode. So that আপনি যদি ওরিয়েন্টেশনটা যদি ওরিয়েন্টেশনও না, in fact orientationটা ডায়োড হচ্ছে, আমি বলছি for example it could come positive, it could come negative. এটা আমি যদি খেয়াল করে দেখেন, আমি যদি এই ডায়োডের পোলারিটিটা যদি একটু ডিসি ভোল্টেজের পোলারিটি চেঞ্জ করে দিতাম তাহলে কিন্তু আমাদের এটা নেগেটিভ আসতো। ওকে, নেগেটিভ -5.7 আসতো, -5.7 আসতো। So still, since the orientation of the diode is in the anti-clockwise direction, that's why always in the upper side it is off, lower side on. Kintu orientation of the diode, where if had the orientation of the diode been in the diode or downward direction, that means clockwise direction, এটা যদি আমার ট্রানজিশন স্টেট ভোল্টেজ লাইন হতো, in that case উপরে আমাদের অন হতো আর নিচে অফ হতো. Only then you could say that it has flipped. Okay, so clockwise এর জন্য উপরে অন নিচে অফ, আর অ্যান্টি ক্লকওয়াইজ এর জন্য নিচে অন উপরে অফ. Is that all right?
Yes sir.
Okay, fine. So next thing we are going to do, determine the input-output relationship, I/O relationship, when the diode is on and also when the diode is off. So let's do for when the diode is on. Okay? The diode is on. So for that, we are going to redraw the circuit. 0.7, 5 volt R, and we're going to determine this terminal, which is plus, minus, minus, plus. Again, we assume, let's assume that it is positive. Vi is positive. Although Vi can have a positive value as well as negative value, but when you're going to treat them as unknown মানে হচ্ছে variable. Variable means it can take on any value between 10 volt to minus 10 volt. So in that case, we assume it to be positive. Similarly, notice the output voltage. It can be positive, it can be negative, but we assume it to be positive. So that's the thing. So if you apply KVL, starting from here, plus Vi, okay, plus 0.7 plus V0, sorry, minus V0 equals to 0. Now you can say why I only wrote minus V0, why I didn't write, incorporate 5 volt or the voltage drop across the resistor. You
So
notice
V0 is going to be determined.
Yeah, so V0, if you
in the
if you want to-
terminal.
Yeah, so what is V0? So V0 is nothing but, if you apply cable starting from, let's say we have a current flowing I, so plus, minus, and if I start a cable starting, if you follow the path to determine V0, so what will be the V0? V0 will be, if I do this, so okay, plus start my cable starting from the ground and will go all the way to this terminal, follow this path. So we have plus IR plus 5 equals to V0. So that means the V0 is already incorporating what? The voltage drop across the resistance plus the DC voltage source. So we don't need to separately put them. So all I need to find out the relationship between V0 and Vi. So this way we found out V0 is equal to Vi plus 0.7. কখন? When is this relationship valid? বলেন তো? As long as diode is on. এখন আমরা জানি diode কখন on? If you want to find out when the diode is on, you have to go back to this relationship. কখন on? The diode is on when Vi is less than 4.3. Also when the time interval is 0 to T1 and T2 to capital C. So এই interval এবং এই interval এর মধ্যে whatever the value of Vi are going to find a relationship. We're going to apply this Vi in this relationship. Apply this Vi in this relationship. So I have obtained the input-output relationship when the diode is on. So next I'm going to determine the input-output relationship when the diode is off. So for that, for off relationship, okay. So we replace the diode with open circuit. Now, since the diode is off, so no current is flowing. I is 0. So it will be the V0. We know that V0 is the terminal voltage which is measured from the ground. And how can we measure the voltage from the ground? We can either go through this path or we go this path. But however, we cannot go through this path because the path is broken. So that means we have to go from this path. So let's say this is our path. So this is the path. This is the path P. So if we go through this path, Start KVL starting from here till this point. First of all, put the sign. Let's assume the current is flowing is I, so there is the voltage drop plus I. If we start KVL, we get plus IR plus 5 equals to V naught. However, we know I is equal to 0. So that gives us V naught is equal to 5 volt. So this is valid when? When the diode is off. So now we have obtained the input-output relationship when the diode is off and the input-output relationship when the diode is on. So let's bring the input-output relationship when the diode is off. So V naught, when the diode is V naught is equal to what? Vi plus 0.7 volt. Okay. Okay. Now we are going to draw the output. So আমরা input output relationship when the diode is off and when the diode is on জানি, and we already know the interval when the diode is, let's say this is our transition state voltage 4.3. Let's say we draw the output voltage here. So this is our T1 interval, TNR is T1 instant. So that would be our T2 instant. That is our T by 2. That is our capital T. So that is our V naught, and this is our T. 0 to T1 to T2. The input and output are there in the same time scale. Now I'm going to draw the output in correspondence with the input. How is that? So first of all, let's find out between 0 to T1, is the diode on or off? আপনারে বলেন। উপরে off আমি নিচে লিখে দিই। On. So if it is on, which relationship that we are going to use? This one or this one? On relationship. Now, what is the on relationship? We found out on relationship is that V naught is equal to Vi plus 0.7. So that means output is going to take on the same shape as input, except that it will be shifted up by 0.7. তার মানে হচ্ছে as if you are holding that part of the signal and pull it up by 0.7. So which means আমি যদি 0 to T1 interval output draw করতে চাই, what I'm going to do, simply এই শেপটাকে কপি করে পেস্ট করব, তার সাথে কত অ্যাড করব? I'm going to add 0.7. তো অ্যাড যদি করি 0 এর সাথে যদি আমি টার্মিনাল পয়েন্ট 0 এর সাথে 0.7 অ্যাড করলে I find 0.7 এবং 4.3 সাথে 4.3, this is a 4.3, 4.3 সাথে 0.7 অ্যাড করলে I find 5. So now this shape and this shape must be same, so we simply copy and paste. Okay. So next we're going to go which interval? T1 to T2. So during this interval, diode is on or off? Off, sir.
Off.
T1 to T2, all the value of the signal is below dotted line, so diode is off. If the diode is off, okay, so we have, so all the value of the signal is above the dotted line. So this, for this signal, diode is off. So when the diode is off, আমরা কি বের করছিলাম? V naught is equal to what?
5 volt.
So that means we're going to have a constant 5 volt. So from 0 to T or T2, I have already done. Now,
So
sorry.
whenever the diode is off, the voltage becomes constant.
Yeah, you see, we already found out when the diode is off, replace the diode with open circuit, and after applying this KVL, we found out V naught is equal to 5.
If it is 0, then it will become constant on 0.
A constant 0. If it is 0, then
Yes,
it's
sir.
constant 0.
Yes, sir.
Now you see this off. It is valid for an interval. This is the interval.
Yes, sir.
So from T1 to T2 at every instant, it is 5, 5, 5, 5, 5. So we're going to consider 5 volt. So now next we're going to go T2 to capital T by 2. So in this interval, so value of the signal is below this transition state line. So that means diode is on. If the diode is on, which relationship we're going to use? We're going to use this relationship. So that means input and output are going to have the same shape, except that input will be shifted up by 0.7. So that means you can imagine that you grab this signal and pull it up. আপনাকে হোল গ্র্যাব করে just pull it up by 0.7. So if you pull it up, তাহলে 4.3 will become 5 and 0 will become 0.7. So they can, the shape of this and shape of this are identical.
Yes, sir.
So next, so that is T2 to capital T. Now from T by 2 to capital T, it is whole negative half cycle, and for this whole negative half cycle, since this value of the voltage, all the value of the voltage is below the transition state line, and which indicates on states. For all the value of voltage, we're going to have diode on state, and we know that the diode is on. The input output relationship would be V naught is equal to Vi plus 0.7. So that means again we're going to, whatever the input has, we're going to grab it and pull it up by 0.7. Just উপরে 0.7 ধরে টান দিব and pull it up by 0.7. তার মানে হচ্ছে, so if it is 0, then we already found out it's 0.7. Okay, and then if it is then 0 এর জন্য 0.7 already পেয়ে গেলাম, and from -10 এর জন্য আমরা কত পাবো? So if I put Vi is equal to -10, তাহলে V naught কত আসবে? -10 plus 0.7
-3.
minus 9 point,
minus 9.3.
and rest will be its input and output are going to take the same shape. So input এর shape যদি এরকম হয়, output এর shape হবে like this. So minus 9.3. Okay, so that is our. So you see what have happened? What has happened? That the part of the signal has been clipped, chopped off, head cut off, and the signal level has been shifted up. All right. Let's say this is the problem we want to solve. V naught. Very quickly. First of all, we're going to determine the transition state voltage. At transition state, we redraw the circuit. Plus Vi minus IR plus minus minus 5 minus 0.7 equals to 0. I is equal to 0. Vi is equal to 5.7. So let's say the Vi is equal to 5.7. Okay, Vi is equal to 5.7. So above diode is on and below diode is off, because the diode is in the clockwise direction. So I can mathematically write Vi T is greater than 0, less than T1, T2, T1 and T is greater than T2, less than T, that is off. because all the value of the signal is below the dotted line. So diode is off. On the other hand, T1, T2, Vi is greater than 5.7, diode is on. Okay. So first of all, when the diode is on, we're going to determine the input-output relationship. Five, 0.7. So for on relationship, V naught আসে কত? 5.7. And for off relationship, let's say we draw the redraw off relationship. That is off. And we are determining the V naught plus Vi R. Let's assume the current I is equal to 0. So if I apply KVL, so again we said that any terminal voltage is measured with respect to ground. So either we can go there either through this path, or we can go there this path. So which path is suitable for us? P1 and P2. Which path we can go?
P1.
P1, because P2 is not possible because there is a
Broken.
line, so we cannot go. So that means we have to go this way. So if I apply KVL, we find that Vi minus IR equals to V naught. So IR being 0, so that gives us V naught is equal to Vi. So this is the input-output relationship when the diode is off, and this is the input-output relationship when the diode is on. So next we are going to draw it.
So it will be a straight line, just like the transition straight line.
Dekhi, let's see how does it look like. So 0, T1, T2, T by 2, capital C. So input and output are in the same time scale. And this is our V naught output waveform. First of all, so let's analyze between 0 to T1. What is going to happen? Is the diode is on or off? You tell me.
Off.
Of
So if it is off, which relationship we are going to consider? This relationship
Vi equal V naught.
V naught is equal to Vi. And now V naught is equal to Vi. What does that mean?
The same curve will
Same input and output are same shape. So that means
Copy.
we're going to see something like that. And then T1 to T2 interval. In this interval, what will be the conduction state of the diode? Is that
will be clipped off and 5.7 a straight line.
yeah, the diode will be on. If the diode is on, we know V naught is equal to 5.7. That means all the interval, every time we're going to find 5.7. So it will be constant 5.7. Again, from T2 to capital T, from T to capital T. So in that case, all the value of this for all the value of the signal, the diode will be off. Now, if all the value of the signal diode is off, what is the input-output relationship?
So the curve will remain the same.
Remain the same. So that means and if next cycle consider, so what I found, so top part of the signal has been clipped off.